Hello, everyone. Thank you so much for joining us today for our Safety and Health Magazine webcast sponsored by SEAM Group. Happy National Safety Month to everyone out there. We're going to let our audience take just a moment to get settled, and we'll begin the presentation in about 1 minute. Thank you. Hello, everyone, and welcome to today's Safety and Health Magazine webcast, Managing Safety Exposures Associated with Industrial Energized Assets to Prevent Serious Injuries and Fatalities, sponsored by SEAM Group. My name is Barry Botino, and I am an Associate Editor with Safety and Health Magazine. I'll be moderating today's event. On behalf of the entire National Safety Council team, we thank you all for joining us today. We'll start the presentation in a couple of minutes, but first I have a few housekeeping items to share with you. As a disclaimer, the views of today's speakers and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not mean the Council or the magazine endorses those items. After today's presentation, we will conduct a question and answer session with our speakers. To ask a question, just click on the Q&A button located at the bottom of your screen, type in your question, and press the send button. You can ask your question at any time at all during the presentation. You do not have to wait for the Q&A to begin. We'll try to answer as many questions as time allows today, but we might not get to every question. The good news is that any unanswered questions will be forwarded along to today's speakers. After this presentation, you'll be asked to complete a brief evaluation survey, but I'll tell you more about that a little bit later. This webcast will be archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, please visit us online at safetyandhealthmagazine.com/events, or you'll also receive a link in our post-event email. All audience members will also receive a resource from our sponsor today in that post-event email, which is a white paper that SEAM Group has published on today's topic. Now let's introduce our presenters. With us today are Derek Hale and Colin Duncan of SEAM Group. Derek is an electrical safety instructor and a lead field analyst. He works with clients to create robust and helpful procedures, policies, and strategies that guide them towards safety success. As the CEO of SEAM Group, Colin is responsible for overseeing global business operations and activities. That includes designing and implementing strategies to fully integrate asset safety, reliability, and maintenance. Again, we thank you all for tuning into our presentation today. And Colin, whenever you're ready, go ahead and take it away.
Let me try that again. Thank you very much, Barry. And how many times we've all done the mute thing by mistake. So welcome, everybody. We are going to run this without video. It helps with bandwidth. Thank you all for joining us. I'd like to really start off by framing the whole discussion around serious injury and fatality prevention. First of all, really by sharing with you SEAM Group's experience over many years and a lot of work on energized assets. The content that Derek and I are sharing today is really a function of the collective knowledge of the team here at SEAM Group. I do want to, Barry made the point about, nothing commercial in here. I do want to be clear. We don't, as an organization, consult on serious injury and fatality prevention. We do have services that are deeply involved in the prevention of risk, prevention of injury in the workplace. But our focus here today is really sharing our learning, sharing our experience, and hopefully providing a new, slightly different perspective on how we go after the reduction of fatal and serious injury events. At Seam Group, we work on over 1.5 million energized assets annually. A number of our technicians are doing high-risk work on a day-to-day basis. So we understand the issues very well, and we have a broad data set to help us really gain some insight into those issues. So let me just sort of jump in with kind of, first of all, I guess, framing the issue itself. First of all, you'll notice throughout the presentation, we will talk about fatal and serious injuries. Sometimes in the safety world over recent years, people have used the abbreviation SIF, serious injury and fatality. You'll also see us use fatalities and serious injuries. It may be semantics. I think philosophically, we choose to tackle the fatal events before the serious injuries. And that's sort of really a thinking lifted from our friends at ORC over the years. The most important thing here is to understand that whilst we have made progress in workplace safety over the last 20 to 30 years, tragically, the data when it comes to fatalities in the workplace would tell us we haven't made enough progress. Anybody in the safety world who's looked at this data will be familiar with it. Sadly, the story is much the same today as it was 10 years ago. And the reality is that for every fatality, we see significantly more life-altering injuries, likely by a factor of 10. So, that is somewhere in the order of 50,000 workers in the US alone each year who are not going home the way they arrived at work. And as a colleague of mine has sort of said on many occasions, the reality is we haven't found any new ways to kill people or cause them to be permanently injured. And that realization, there's no new ways of getting people seriously hurt and killed in the workplace, and yet we're not making progress, should really be focus point number one for us as safety professionals. I would also say, I learned about 10 years ago now, I had the very humbling experience of working live on in a meeting room in Scandinavia for a client, looking at 34 fatal events that they had experienced in their business over the previous 7 years. Looking at that data, looking at each of those individual events, the realization of an individual or on 2 or 3 occasions, several individuals being fatally injured in an event, it's something we'll never forget. It's also a reminder that fresh eyes on broad sets of data does allow us to find new ways of looking at seemingly unrelated events. And that's really my way of getting to that's what we're trying to speak to today in this webinar, and indeed in the white paper that Barry mentioned earlier. So we firmly believe that it's necessary to take a slightly different approach here. And whilst you might argue that the pivot here isn't especially radical, the pivot being to focus on energy in the workplace, rather than focus on incidents or events, I do think it's an important pivot. And it's an important pivot because the reality is that for the better part of the last 3 decades, I believe that as a profession, we've allowed things like pyramids, rate management, worker behavior to allow us to get focused on some of the wrong things. And what we really need to do is start with an unbiased focus on risk, properly assessed and properly managed. Is there a risk that all of our acquired knowledge, all of the complex systems, management systems and rules and procedures we built might actually cause us to miss the essence of our risk elimination and mitigation, risk the essence of how to get after these serious injuries and fatalities. And in that context, do we do enough to educate from top to bottom on a simple way to understand the thing that might cause harm, which is fundamentally the energy in our systems, in our assets, in our workplaces? And it's interesting to me when you look at much of what has been published over the last decade on fatal and serious injury events and their prevention, what one tends to see is a layering based on existing approaches rather than something that takes a fresh approach at the issue. So I hope that as you go through the next 40 minutes or so, we offer something that might be a different angle, a different way of looking at what is clearly a pervasive problem. As we look at the legacy, the history, and I'm going to keep this section pretty short, there are a number of folks who've written about the problems of the legacy thinking here, whether it's Heinrich, Bird. You could argue that there was a core premise for tackling incident and injury causation that really drove thinking a very particular direction. And it really is the anchor for a lot of modern day safety programs, but unfortunately, it is fundamentally flawed. And I'm not going to expand in great detail on why it's flawed. I think I'm happy to provide references after this webinar. There is some really good material written about the flaws in these legacy models and legacy thinking, including a piece that I think is one of the better written pieces and may have a bias here, but written by two of my old team at BST, Don Martin and Alison Black. And as I say, happy to provide any of those references after the webinar. What I do want to say is that, Heinrich and Bird were correct in that a frontal assault on mishaps could have a knock-on effect on some of the more serious ones. That is reasonably accurate as a statement, but their theory of causation as it relates to major injury is inherently flawed. And I was CEO of BST when we started a research group just over 10 years ago now with our good friends at ORC HSE, with an initial cadre of 7 organizations where we sought to better understand the underlying dynamics behind serious injury and fatality events. The initial cadre of 7 organizations actually subsequently grew to over 35 and provided a rich vein of data to better understand incident causation. And at the core, what we found that was whilst the relationship varied depending on the work environment, most minor incidents have relatively little potential for fatal or life-altering injury. And I don't need to belabor the point, but I think we've all heard the stories of facilities that went 2, 3, 4 years without a recordable, only to have suddenly out of nowhere, apparently, a fatality, or indeed several. At one level, we can think about Deepwater Horizon as being a prime case study into the problem of getting very focused on your incident and case management and missing the systemic risk. But perhaps, a simpler way of looking at it, I remember getting a phone call one day, probably about 8, 9 years ago now, from a chemical client I'd been working with for a number of years. They had been working to, really make some systemic improvements across their operation. And in one particular facility, I received a phone call from the safety manager for the division. This was a facility they'd not long since acquired. They'd had 3 serious incidents in the prior month after apparently 3 years with nothing at all. And rather than reacting to the incident, I think the only question we should ask in that situation is, was the underlying cause there all along, or did it only just suddenly emerge? And of course, as safety professionals, when we ask that question, we kind of know it's self-serving, right? We know that the reality is in almost all cases, we find that the answer is it was always there. It just needed the right set of predeterminate conditions to align for the worst possible outcome to actually occur. And so we have to think about the problem differently. That's very much where the research has come from. And, I think we've learned something from that research. It's now time to pivot to different ways of thinking about the solution. And, excuse me, to that point, I do want to highlight something that is inherently problematic in understanding this issue. This slide speaks to the challenge of two seemingly similar events at first pass. Both incidents are recordable. They require a similar number of days away from work. However, when it comes to the fundamental difference between the two, if we think about energy as a way of evaluating the extent to which those incidents were different, we find that clearly one incident is significantly different to the other. And this problem of how we measure and how we classify, I think is well recognized in the safety world. What's perhaps problematic is that we haven't really made progress over the course of the last decade. We still have no common framework for serious injury and fatality reporting. Yes, OSHA has a severe injury reporting framework, but since I think that was implemented in 2015. OSHA themselves think that only about 50% of those severe incidents are reported, and it's only covering a small, I think it covers about 60% of states nationally. A lot of states who have their own OSHA framework, they're reporting it differently. So we've got real problems with getting visibility to the data. It's also interesting to me, if you happen to go into the OSHA website and look for fatality and serious injury prevention, look for data, look for anything that advises on intervention strategies. Still at this point, there is nothing on the OSHA website. There aren't publicly available solutions, interventions, methodologies for addressing this challenge. So we see the data causes noise. The data causes to look at the wrong issues, the wrong problems. And fundamentally, if we had reported these two incidents, not based on the outcome, the way we might think about it in our 300 log, but rather thinking about it in the context of total available energy, we might see some really quite radically different patterns in our data. And that really is fundamentally our thinking about what has to change here and what we do going forward. So we have a data challenge. The data is lacking or it's confusing. And most companies don't really have an effective way to bridge the data gap. I do think that a focus on fatal events is way too narrow, and interestingly may actually have some of the same problem of commingling that we talked about earlier. If instead we orient towards the energy, we might actually establish a program that is structured in a way to gather the data differently. And that might allow us to design an intervention program that more effectively focuses on the risk. And if we ask ourselves, do we have a risk-based energy assessment process? And is that at the heart of how we tackle fatal and serious injury prevention? So in the interests of keeping us moving along here, there are, I think, some really good summary reports that capture a lot of these issues. I'll speak directly here to friends at the Campbell Institute, which of course is part of the National Safety Council, and a really excellent paper they published back in 2018 as a good reference point for some of these issues, indeed some of the reading references and background data. I will argue, with the greatest respect to my friends at Campbell, that what we still didn't get to in that paper was a clear path to intervention. And as I said earlier, I hope what we're offering here today is some sense of how we might tackle an intervention that really gets after a structured and disciplined approach. And that is because at the heart of it, a lot of what we ultimately find in terms of causation is really quite predictable. And if we look at many of the keys to foreseeing and heading off serious incidents, we tend to find that at its heart there's some basic high school physics. And this, at one level is a fairly straightforward example, but we could look at multiple different scenarios where we can think through the risk and the potential outcome based on energy. In this example, a 200-pound worker climbs to the 4th floor of a processing facility. At 60 feet above the plant floor, his or her body, probably a his, contains about 16,000 joules of potential energy. So if the safeguards that are in place fail, that worker hits concrete at 42 miles an hour. And my point being here that we can calculate the energy, we can calculate the energy potential, and that helps us find a very clear path towards the likely outcome. And in amongst all of this, also recognizing that at its heart, we should understand that any safety system that is designed to assume that people don't make mistakes is designed to assume that it will fail as a system. And I'll speak more about that in a moment. So that's, gravity can be one source of energy. Most safety professionals are fairly well schooled in the different types of energy, be it thermal, electrical, nuclear, gravitational, we talked about hydraulic, we understand the different types of energy. The question I would have for each of you is, do we have the level of education and awareness of both energy, where it is, what happens when it's released, what the consequences are? Do we have that knowledge at our senior operations management level, at our mid-management level, supervisory level, frontline level? And I say that not because the solution here is about teaching people about energy, though it will certainly help, but because you can't design a system if people don't understand what's sitting inside of that system. And the thing that gets people hurt is the loss of control of energy when it interacts with human beings. So we really want to focus on understanding that energy, understanding how it's likely to interact with people negatively, and making sure we build a system that really goes after that. One or two final points, and then I think I'll hand over to Derek. First of all, let's not miss this kind of latent energy. I referenced earlier 34 fatal events I was involved in looking at a number of years ago. One of the things that stood out for me were several incidents where there was latent energy built into a system that was perhaps related to geological energy or to adjacent energy sources, underground water wells pressurizing a wall. Sometimes I think we miss the opportunity to analyze more broadly adjacent energies and latent energies and really allow those to inform our thinking about what's going on in the system. Finally, and I referenced this a moment ago, the essence of our thinking and our approach here is that this energy is about systemic risk, and we have to look for a systemic solution. Training people to be aware of energy, it's part of the solution, it's not the solution. Those of you who followed recent writings from some of the human and organizational performance authors, Holnager, Sidney Decker, Todd Conklin, Rob Fisher, have all called out that we really need to get away from focusing on the front line and worker behavior and really think through a systemic approach. And that's what we're really trying to model out here, is how do you tackle this issue systemically? And on that note, I'm going to hand over to Derek, who's going to talk you through an overall framework we believe will be effective in tackling that issue. Derek.
Thank you, Colin, and good afternoon, everybody. And at the risk of jeopardizing the momentum that we've built here, I do want to point out that I may be taking this webinar in a vehicle, but I assure everybody that it is fully parked. This is National Safety Month after all, so I just wanted to put that out there as a quick programming note. But let's move on to asking too much of people. So, as we talk about the human factors that can pop up in the workplace, focus on them. It surely can help on the injury continuum, drive you past simple near miss to a direct hit, and an injury, if you will, and that focusing on the human factors can reduce that. So what are we talking about when it comes to the human factors? We're talking about training, right? I'm a huge believer in training. I like having the formal conversations on hazards, potential hazards, how to act accordingly. I am a trainer, so I'm kind of bought into that for sure. Reinforcing PPE use, engaging in the casual day-to-day conversations with employees on what they're seeing or how they're doing, the course of their job throughout the day, what they're witnessing. But even with all those layers, putting the hat on the hat on the hat, you're still relying on the employee to be as sharp Monday, mid-morning after coffee and all that, and then have that sharpness carry all the way through Friday, right? And relying on that, we could say, oh yeah, absolutely, I keep my head about me the same throughout the week, but it's tough to say what somebody might be going through when we're talking about the human factors. In 2018, NFPA 70E introduced the human factors, so in their Annex Q, and that definitely points to maybe we need to start focusing on what the modes of human error are. And looking at that last bullet point there, preaching to the choir, but PPE only makes us, safe against death, right? The goal of PPE is to make sure that you don't die, but you still can be incredibly hurt. If we can go to the next slide. So when we're looking at fatalities, obviously fatalities are the worst of only two possible outcomes. It's not necessarily a continuum of outcomes that could have been affected. It is the worst case, right? So when we're talking about the FSIs, we're talking about the serious injuries, we're talking about fatalities. If that dropping load, to kind of look at this bullet point here, if the dropping load misses the worker and the worker is uninjured, that's ideal. That's the tree falling in the forest and somebody maybe hearing it make a noise, but if it hits the worker, they're done for, right? Same with the ammonia pipe burst outside. If it happens outside, it's a leak. Maybe we focus on it. Maybe it's something that we circle back on, talk about, but is it something that we're taking as incredibly seriously as if it were to, act on humans and kill everybody that might be in a room if it were to burst inside? So when we're talking about these potential injuries, these latent or these potential energies rather, and these latent injuries or energies that are stored in the workplace, if we have employees near them, that's when we need to start focusing on how can we control that better. And speak the last bullet point there, the challenge for the safety leaders is to not only figure out how to downgrade the exposure, and go for that administrative level on the hierarchy of controls, but also how to eliminate it and take it all the way to the top of the pyramid, if possible. Let's hop over to the next slide. So when we're looking at the improved systems thinking, we're looking more on the design, the reliability, the maintenance, and the safeguards within the workplace and within the areas that we have our employees exposed. The planning. Sorry, I think but we need to look at a design that handles more than just relying on the human factor, and relying more on a systems approach that is baked in safety in the workplace, as opposed to relying on the employee performance. As I said previously, if we have a sharp employee on a Monday, are they going to react the same way at the end of the day on Friday when they're thinking about the game that's coming up on Sunday? Or should we more build safety into the process and look for more fail-safe designs, look for more engineered solutions, more middle to top of the pyramid as far as the engineering, the elimination, and so on. If we could pop to the next slide. All right, so let's we're going to look at 8 steps for FSI prevention, just to take in preventing these fatalities or serious injuries. So, I swear this isn't the sales pitch part, but we help clients monitor and maintain over, like it says there, 1.5 million energized assets. And again, that isn't to brag necessarily, but to say that we see a lot of stuff across a multitude of industries and different applications. And the second bullet point kind of says it all. Most have potential to kill, whether it's voltage that can electrocute, whether it's air pressure that can push air through the skin, or contaminants through the skin, cause an embolism, or a highly reactive gas like silane that just loves to blow up when given the opportunity to be in the presence of air. So we see a lot, and so here over the next couple slides, we're going to go over 8 steps that we've sort of distilled it down to when we're talking about a systematic approach to reducing those FSIs. Next slide, please. So first and foremost, where are our energy sources? So what is in your facility that could, worst case scenario, facilitate an FSI? What could act on employees and cause a fatality or serious injury? That last bullet point is very important, to me personally, just from my own experience, as far as touring the same facilities and trying to keep an eye out for different hazards within the facilities that I was in charge of. But over time, I found that your eyes really do sort of follow the same path when you're walking through the same facility over time, right? And having a set of fresh eyes always lends a better perspective. It lends a new perspective, not only for different habits that we may have formed as safety professionals, as far as, hey, I came up with electrical safety, so I'm going to check and make sure that there's no knockouts missing in this junction box, or I'm going to make sure that all the covers are on these panel boards, versus the person that came from construction, and they're looking for more fall hazards, more physical injuries to the employees that are related to the physical hazards around them, as opposed to just electrical hazards. So having that fresh set of eyes, it just lends a different perspective. Next slide. So calibration of energy levels. So here we're talking about that energy pyramid again, or that risk control hierarchy again, that level 2, right? Substitution. So I'll be honest, we still have clients that we find that use 120 volt control circuits, right? You still have some areas where they're just not really segregating out the different voltages within control panels that maintenance technicians need to get into on a very regular basis. And so they may be going for a small fuse or a small breaker, or just a little control switch that is by all accounts touch safe, lower than 50 volts, but within the panel, all throughout the panel, you still have 480 popping in, 120 popping in. And that's something that we're seeing that's still very common across industry as a whole. And that's really low-hanging fruit for us, because there's a good, or I guess a bad history, right, of employees in different settings and different operational settings losing fingers without control voltage being properly lowered, right? Or if there's a lack of control voltage and they're just still trained to manually press in motor starters, that can have dire consequences. So really looking at the energy levels and taking a look at what it is that we're putting our employees in front of, and what it is that we actually have in our facilities throughout those day-to-day interactions and all those day-to-day touch points for the employees. Next slide. So human proximities, right? This can be sort of the toughest to determine. If you've had kids, I don't know how much of the crowd I'm speaking to here, but you probably know the struggles of baby proofing your home, or even if you have a dog and you have to make sure that they're not chewing on everything that they shouldn't be, right? That's and that's just in a place that you've made to live in comfortably. And unless you're, Tim the Toolman Taylor, you probably don't have 480 volts AC running through your house. You probably don't have a, clean, dry air piped through through your, kitchen, right? So now take that stress to an industrial facility. So the easy starting point for when we're walking through is, where are the points of operation? Where are employees standing? Where are employees working? Where are they manipulating whatever product they have to work on, control panels, controls, etc. From there, where's the path to the break room, the path to the bathroom, path to the time clock? So looking at those areas, what are your proximities to hazardous energy within that, that path of travel? And that only accounts for normal operations, right? So that's, everything goes well. I go in, I press the buttons, I make the widget, I hit the break room, I go back, I hit the restroom. That's a good day. Now, let's talk about if something fouls up in the operation and people have to come in and fix something. In the past, I've had to assess different wastewater treatment plants, and I'll remember one that was in the Columbus area, and there was an aerator basin. And if you know anything about aeration basins, it is one of the biggest hazards in wastewater, because if you were to fall into this tank of brown liquid, it would be a bad day just from the smell, but also you sink because there are air bubbles throughout the tank, and your specific gravity just isn't enough to give you buoyancy, so you sink. Now, looking at the aeration basins, everything looked great because there's a guardrail around everything, guardrail, mid-rail, toe board, everything looked good except for a walkway across the middle with a valve there, and no additional guarding for the walkway. And speaking with a maintenance technician on site, asking him, hey, what exactly is that for? He told me, oh, well, every once in a while something gets jammed, so we have to fiddle with that. So prime example of when everything goes well, when the toilets are flushing right and the wastewater treatment plant is going as swimmingly as a wastewater treatment plant can, everything is wonderful. But once every week or once every couple of weeks, somebody would have to go out there and risk falling into these basins that they would not be able to escape from, just to wiggle a valve. So to put that to your facilities that you're seeing, are we are we tracking everywhere that employees can be and not where they should be on a good day? You know, when we're looking at these human proximities. To the next slide. Modes of failure. So this is one that sort of comes with time and just seeing a lot of different, failures. Quick story. So kind of a fun one. Walked client site that had a lot of conveyance, a lot of different conveyors running through the different rooms within this building, and the conveyance was run with a slew of 480 electrical motors, right? Just like most of industry. Some were mounted in a way where the motor was allowed to vibrate, had a little bit of travel, and over time, the conduit bodies that were feeding the wiring into these motors would shake loose and come off. And this wasn't part of their normal PM to even look at this. But if left, unchecked, those wires would rub against a sharp metal inlet into the motor body. And the failure here is that, when that motor body wears through that insulation, gets to the conductor, it's going to cause a short, might even cause an arc flash, depending on if multiple wires wear through at the same time or what have you. So if that facility had an arc flash survey and coordination study done, then the breaker upstream should trip, no problem, right? So we have an arc flash potential. Maybe it's not that big because the proper circuit breakers are in place, everything goes well, everything goes according to plan anyway, maybe not well. But let's say this happens in the middle of the night, happens on third shift, and it's the end of the month, and they're trying to meet their metrics. So a big part of their conveyance just went down, and they're trying to get their job done that night. What do you think is going to happen next? Will they find a trip breaker and just try to turn it back on, re-energizing that circuit and causing yet another arc flash? Or are they going to start going down the line and investigating this tripped breaker? Just different things to think about as far as what is the worst case scenario that could happen with just something as simple as the vibration on a motor. To the next slide. Calculating probability. So again, I'm not the sales guy necessarily, but when we talk about a third party being important to developing safety strategy, this is it, right? So we've all heard I've done this for decades, I've done this 1,000 times. And maybe those folks that say that have been dancing in between the snowflakes and the blizzard, or maybe they're wrong. Maybe they don't understand different changes that have happened to make something more hazardous in their area. But that's the level of probability calculation that we see in a lot of different facilities these days, right? So to go to another example from that same exact facility where I was walking with the conveyance and the motor bodies, they had a lot of cardboard dust accumulating in their facility, so they decided to put in a dust collector, and they were very proud of it, and as they should be, because it was the right thing to do. And when they installed this dust collector, they placed it in front of a 150 kVA air-cooled transformer, and that dust collector just decided to start spewing dust at that transformer. Everybody was paying attention to the dust collector, couldn't even see the high probability issue happening behind it, which was, potentially combustible dust fouling an air-cooled transformer, going through the vent and potentially causing a huge issue, right? So when we talk about probabilities, just seeing different instances of things throughout industry, and being able to take a step back and see the bigger picture within your facilities is just absolute key. Next slide. So here's the pyramid, right? Talking about the middle of the hierarchy, right? Talking about engineering, administrative tiers. The substitute tier could and should be used. Same with the elimination, but a lot of times it's not very, it's not very practical to operations, right? But can we substitute things out? Can we, instead of having high pressure pneumatics throughout the entire facility, maybe just have an air booster placed at the different pieces of equipment that require higher air pressure, Usually we think of this and we jump to like hearing protection or chemical exposure when it comes to administrative controls, and those are valid uses for administrative controls. But let's consider also the hazard training, the procedures put in place to keep employees safe, right? Even better, let's look at engineering, utilizing lockout tagout, installing interlocks, or in the case of control cabinets or MCCs, that might get that high traffic from the maintenance employees that we talked about earlier. Let's look at making the control voltage separate from the supply power, making an enclosure for the transformer at the top of the panel and segregating that out, right? Using these these engineered controls to make safety inherent to the process, that our employees go through every day without having to worry about the human error of it all. On to the next slide. Inspection and maintenance. So the Monday morning quarterback in your injury investigation will always be able to clearly say, oh, we should have done better on this maintenance piece, or we should have looked at this. I don't know why we're not inspecting that. And that's great. So, but it's not helpful at the time, right? So identifying points of potential failure, like that conduit body shaking loose from the motor, and incorporating that into regular PMs is imperative to staying on the left side of that, the pre-incident side of the injury spectrum. And, that's what happens when you get that third set of eyes coming through and pointing those out. It's actually part of their PM process today. But another preventative item you can start on today is just the simple infrared thermography, right? See where you may have some issues down the road, maybe just some plain inefficiencies that need to be addressed. Maybe some vibration analysis. But all it takes is just a company to come out with an infrared camera, take some pictures of panels with the covers off, and you have a clear view of what could potentially happen down the road, as opposed to having to deal with that that person that's always in the investigation process. That's the Monday morning quarterback, right? Next slide. And finally, so involve the front line. This one's huge, probably my favorite, right? No site inspection, to me, is complete without speaking to the frontline employees. These are the people that, as a function of time, curiosity, dedication, development, they become something of subject matter experts in their area or in their task. And while, you can't necessarily rely on everybody to stay fresh throughout the day, you can absolutely rely on them to have had some pretty valid observations throughout their time within their task, within their role. And, not to harp on the benefits of, third-party inspection again, but as a guy going in and conducting these inspections, when I speak to the rank and file production employees away from supervisors, they usually have an idea of some unique hazards in their area that they've noticed, or things that they do that might not be regular tasks, but that they still have to perform as part of their day-to-day, that they know they shouldn't, but they still bring it up, right? And it's usually to capture this information for a preventative, safety program to make your process better, as opposed to if a serious injury or fatality were to occur and OSHA comes in, what are they going to do? They're going to do the exact same thing. They're going to interview your employees. They're going to have them away from the supervisors. And they're going to say, hey, what could be done better? What do you see in your workplace? And the employees are going to have that same information, but instead of that information going into a helpful preventative safety program, it's going to be used to build a case against you, right? So with that, we're gonna put out a poll question here, and I'm going to turn it back over to Colin afterwards.
All right, thanks, Derek. We'll give folks another 10 or 15 seconds as you let me know when we're good. Just interested to see responses to the question. Okay, so the inspection list is growing and changing depending on what we find. 60%, we generally only have time to keep up with basic PM. So people are making good progress, which is fantastic. It would be fascinating to dive more deeply into this question, as Derek spoke to. Philosophically, as an organization, based on what we've seen, we think a significant part of the solution to the challenge of fatalities and serious injuries is in actually the integration of disciplines. Thanks, I think we can close that now. And let me just kind of bring some themes together here. So we saw over the last 20 or 30 minutes, this 8-step model, and I'm not going to kind of dive in detail here to review, other than to say we firmly believe there is a clear path here that is both risk-based, oriented in understanding energy, the sources of energy, where your energies reside in the facility, how it might be released, and what the consequences can be. And that's really at the heart of this 8-step model. Locating it, calibrating on the energy levels, understanding, as Derek put it, human proximities, points of operation, the reality of how people do the work, not the way the work was necessarily planned. So, normal operation versus abnormal operation, we've got to consider all eventualities. Understanding the modes of failure, what might happen, how does that play out, what are the consequences? And then really from there, understanding clearly probability and probabilistic analysis. And look, at one level, I realize you could look at this whole presentation and say, Colin, this isn't really new. This is about taking a risk-based approach. It's about having a systemic model. It's about really, understanding probability and risk and managing it accordingly. And yes, it is. But, I'm sometimes reminded, if you go back and read the work of, Kletz, of James Reason, some of the early authors in safety of 30 some years ago now, and look at what we have seen happening in the world of safety over the last decade, I think sometimes we do well to take a step back and get to the root of our discipline, which has to be risk-based, and it has to be about addressing high-risk scenarios systemically, and not having your primary defense mechanism be people doing the work as intended and not making mistakes, okay? And so we want to focus on getting after, at the middle of the hierarchy controls. I'd actually argue, ultimately our goal is to eliminate, substitute as much as we can. And in doing that, we have to have the people who understand the work really engaging with us to ensure that we understand the risk involved in that work. Optimizing our inspection and PM regimens, and involving the people who have their hands on the tools, right? And there's a general truism that if we give the folks doing the work the right knowledge of the risk of the energy and the systems and the equipment they're working with, on a day-to-day basis, they'll do a pretty good job of letting you know what could go wrong and where it's likely to go wrong. However, that's got to be tackled systemically. And that really is at the core of our philosophy. And then using what we learn systemically to design better engineering. And I just, in passing, want to give you one good example of that. At SEAM Group, one of our areas of specialism is arc flash hazard assessment. And one might argue that, an arc flash hazard assessment is really a combination of, the right administrative controls, making sure you understand the energy, you've got proper calibration on that, and then we're guiding people on the right use of PPE. But, we can get upstream of that. We now have a technology in arc flash relays that allows us to massively mitigate, reduce the amount of energy dispersed in the event of an arc flash. Ultimately, a good systemic approach to that particular risk is about redesigning equipment to largely eliminate the possibility of an arc flash causing permanent disability or death. That technology is available to us. And again, it's getting way upstream and getting much higher in the hierarchy of control. So all of that to say, as we pull all of these pieces together, do want to finish by helping you understand why we have the paradigm that we have at Scene Group. So we work with our organizations to help them improve the safety, the reliability, and the maintenance of energized assets. And it is our firm belief that when an organization removes the silos we typically see between our safety group, our reliability group, our maintenance group, and we have them working cohesively, we have them working in unison and really collaborating to understand risk, not just from a safety point of view, but risk from an operational perspective, we get much, much better outcomes. So that's sort of the core of our philosophy and why we believe that this slightly different approach to the management of fatal and serious injury causation can really move us in the right direction, because I think when we do this, we necessarily cause our safety, our reliability, and our maintenance folks to work together and collaborate on this stuff. So, thank you all for joining us. I hope that's been thought-provoking. And I think we've got a few moments here I'll hand back to Barry if anybody has any questions.
Great. Thank you very much, Colin. And thank you, Derek, for sharing your expertise with us today. Before we start the Q&A, I want to let everyone know about the evaluation survey that we're asking you to complete. The survey will open in a different screen after this webinar. And your input is very important to us because it does help us to improve our future webcasts. And let's go ahead and get to a couple questions we have that came in here. Derek, we'd like to start with you. The question is for you is, how is this approach different than, say, simply training your people on risks and exposures?
So I would say that the key difference there, sort of what was discussed prior, was, we can train our employees, all day, every day till we're blue in the face, but without the push for baking safety into the process, we're still going to see these serious injuries and fatalities that are based in modes of human error, right? It's definitely a growing topic within the safety field. In 2018, like I said, NFPA 70E added, or put focus on Annex Q for the modes of human error, and in 2021 they put a bigger spotlight on it. So we're just going to see this topic grow and grow and grow. So the more we can make safety a part of the design step when creating processes, when creating facilities, the less we're going to have to rely on, hoping that training sticks, or hoping that, somebody remembers their training Friday afternoon.
And if I might add to that, Derek, I think the recognition that we're talking human factors in systemic design is a recognition that our design should consider the reality of human factors and the high probability of human failure. As I said to somebody I was talking to last week at a dinner, the one thing that we can be certain of is that as human beings, we will fail. Give a human being a task to do 1,000 times, it's basically guaranteed they'll fail at least once in that 1,000 occurrences. So let's not design a system that doesn't recognize the reality of human frailty and the flaws that we all have. And that's why it's different to training. Training people says if we train them enough, they'll do it more reliably. They may, but we're still not going to break the fundamental and underlying data as it relates to the likelihood of people failing.
Great. It looks like we have one more question, time for one more question today, gentlemen. And Colin, I'll ask you this question from one of our attendees. How do you ensure supervisors, managers, and frontline workers have visibility to the data from the analysis?
It's a really great question, and I'll keep the answer extremely short. We've been working on that. We believe that some kind of visual augmented reality tool, something we've been working on is what we're calling a heat map that helps you really identify energy, sources of energy, and associated risk using visualization tools. We think that's probably the most powerful way of putting this information in the hands of everybody who needs it, whether it's leaders, managers, supervisors, frontline workers, people in the design shop, doesn't matter. I think that visualization of where the risk resides with the ability to, if you like, click down to understand better what that means, what it looks like, and how it might play out. That real-time visualization is probably the most effective tool that we have. And I think with some of the technology now available to us, we're close to being able to put that in the hands of people real time.
Great. Well, thank you, Colin. And unfortunately, folks, we have run out of time for questions today. Again, we hope you take just a few moments to share your feedback via our survey. I'd like to thank our outstanding presenters today, Derek Hale and Colin Duncan, everyone from our sponsor at Seam Group, and of course, all of you who joined us today. Once again, happy National Safety Month to everyone. This ends today's Safety and Health magazine webcast. Take care, everyone, and have a safe day.